right? So, if I want to think back about the sine function, or the cosine function, or the tangent function, or secant, cosecant, cotangent, any of the 6 trig functions. If I want to think back about that, okay, what is the independent variable? What do I put into that function? What is the dependent variable? What do I get out of that function? We need those as we go forward today, tomorrow, and the rest of the semester. Going forward, because we're going to start graphing these functions. So we need, this slide is crucial for the rest of the semester's topics. So what is the independent variable in a trig function? What you put in to sine, what you put in to cosine.
Maybe like the measure in degrees or radians
Of an angle. Yep. So our independent variable is the angle, or the angle measure, if you will. Okay? What's the dependent variable then? I can't understand.
Side lengths.
Side lengths? What do you mean side lengths?
Because you do like sine, say like 37 is equal to like 12 over 18, and 12 and 18 are the lengths of the triangle.
So the lengths of a side, or the side of a triangle, if you will?
Yeah.
Okay, alright, okay, so the side of a triangle.
I'd say it depends on the situation, because like as we learn, all of them equal different things, like x or x over y or 1 over x. So
Okay.
that's the dependent variable.
So your dependent variable could just be like a number.
Yeah.
Okay, a value. Okay, which we could apply it to be the side of a triangle, or we could apply it later on. We're going to apply it to be maybe the depth of a wave or something along that lines. The height off of the ground on a Ferris wheel or something like that. Okay, all right. So it's, for now, we're just going to call it some number value, or some numerical value. Okay? So if we wanted to graph the sine function on the xy plane, what would be our x's and what would be our y's? Based off of that, what would our x values be? What would our y values be? Angle measure would be the x, because your independent variable is the x. So this down here is going to be your angles. Okay. And then our y's are going to be numbers. Yep. Positive and negative, right? So we could even go positive angles there, and we could go negative angles down here. Right? Love it. Love every part of that. What we're going to do to graph the sine of x, and that's what we're going to deal with first. Okay? So what we're going to do to graph the sine of x is everybody is going to need to get one of these sheets. Okay? So you're going to come up and you're going to grab one of those sheets. Okay? And then at the same time, everybody is going to come up and grab one piece of spaghetti. Okay? Right? So if you want to come up, if you're sitting next to somebody, you want to come up and grab like 3 of each and pass them out, that's fine. But everybody needs a piece of paper and a piece of spaghetti. Go. So, on that piece of paper that you have on the front side, we are going to be graphing the sine of x. So y equals sine of x. Okay? All right? At the bottom of that piece of paper is a unit circle. Okay? It's just going to be our unit circle. Okay? All right? So, one radius, or the unit is 1, 2, 3, 4, 5 squares. So that's why up above, you've got a 5 square up and a 5 square down graph. Okay? So that's our unit. Now, sine is what on the unit circle? Which one? Y, because I heard of both. Okay, so sine is y on the unit circle. So what you're going to do, and I'm going to demonstrate, you're going to use your spaghetti. Now, if you want to break off your piece of spaghetti, that's fine. If you just want to put a mark on your spaghetti, that's fine. However you want to do it, that's you to do. Okay? So for me, I am going to go up here, and I'm going to use, I'm just going to use a line. Okay? So these are broken up into 15 degrees in each quadrant. With me? Okay? So the sine, and then I believe up here, up here they're by 30s. So we're going to go 30, 60, 90, etc. Okay? And then we can adjust for 45s. Okay? So I'm going to measure the y value, because we're dealing with sine, so I'm going to measure the y value of 30 degrees. Okay. Then what I'm going to do is I'm going to go to my graph, and this would work in radians too, if we wanted it to. Then I'm going to go up to my graph, and I'm going to go up to 30 degrees, and I'm going to measure that out, and I'm going to put a dot where that is. Okay. Then I'm going to go to 60 degrees. And I'm going to measure that out. I'm going to drag it up to, in my case, I'm dragging it up. And I'm going to put a dot. I feel as if mine is off, because that should be at where I'm at for 90. Yeah. Oh, I know why, because mine's this graph is tilted. Right? I feel my graph is tilted. I guess I can't get it untilted.
Isn't this like
And then you're going to work it all the way around your circle. Now, what happens if we go below the x-axis? Then we're going negative up on the upper graph too. Yep. Okay, so we're going to go below the x-axis on that. So work out the entire sine graph. All right, so you should have gotten, so at 30 degrees, okay, the cosine is square root 3 over, or excuse me, the sine is 1/2. So you should have been at 2.5 blocks, right? And then at 150 degrees, you would have been back at 2.5 blocks. And then at 210 degrees, you would have been down 2.5 blocks. And then you would have been 2.5 blocks again right there. Yes?
Yes.
Okay. And then you should have been all the way up to 5 blocks at 90. And at all the way down 5 blocks at 270. Yes? And then had you done the 45s, you would have been somewhere like right in here, and then right in here, and then right in her. I think no. 45 would have been there, so that would have been like right about there. Oops, down a little bit more. Right about there, and right about there. Erase that one. Love it. And then if you would have done the 60s, or you'd have been like right up, oops, a little bit more than that, but we're close enough, and then close enough, and then close enough. And so then we can draw this in now. Okay? And so we can draw this in. So it starts at 0, and it goes up, and then it comes back down, and it goes through 0 at 180, and then it comes back, and it goes, and we're right there. Yes? Well, my question to you is this. What if we would keep going? What if I would go to the next one, and the next one would have been 390 degrees? Where would we be at 390 degrees? At 2.5 blocks up. Okay, and then back up in here, and then 450, we would have been up at the top again, right? So it keeps going on and on and on and on and on forever in this pattern. Extension number 2. What if I would go to negative 30 degrees? Negative 2.5 blocks. Negative 90 degrees would be down here at negative 1. It would extend through like that. Yes? Okay. Oh, and you want to come up here? There's probably a little more space. I'll move my stuff. Okay. All right. Love it. So it keeps going on in the wave function forever and ever and ever, right? But does it ever get bigger than 1?
No.
Does it ever get smaller than negative 1? No, and we learned that on the obviosities, that sine was always in between negative 1 and positive 1. And so the wave is never going to get out of there unless I change something, unless I transform it, which we'll start learning tomorrow. Okay? All right? Love it. Okay. Now, let's do cosine. Flip your page over. Okay? So now let's do cosine. Okay? Cosine is what on the unit circle? X's. Okay? So now instead of measuring vertically on your unit circle, and we put another unit circle on the back there, same thing as before. Now instead of measuring vertically, now we're going to measure horizontally. So now I've got to go up here. So like this is the 30-degree one right here, right? Okay, so now what I've got to do, let me bring this down a couple of notches here. Okay, and now what I've got to do is I've got to measure horizontally from that point. Okay, so and then that would be then what I transfer to my vertical. So then when I come up here now when I come up here, now I've got to transfer that to verticalness. Oops. And then I go from there. Okay? Which is a lot easier for you to do than it is for me to do. Okay? Go, Fo. Go, Fo. So, while we're eating cookies, okay? So, at 0, cosine should have been up top, right?
Yes.
So that should have been 5 blocks up. At 90 degrees, cosine should have been 0. At 180, cosine should have been 5 blocks down. 270, it was back to 0. 360, it was all the way back up to 1. At 60 degrees, we would have been 2.5 blocks up, which means then at 120 degrees, we would have been 2.5 blocks down. 240 would have been 2.5 blocks down. 300, 2.5 blocks up. Okay. So this one, the cosine curve, starts up, down and through, curving back up and through and curving. Agree? Okay, the valley, if you will. Okay. Now, if we would continue on, then it would go back, so it would come back down to there. No, at 60, it was at 30. There it would come down to. So it would come down to here, and then it would cross over there. Likewise, back over here, it would come to there, and curve over and through down, and it'd be keep going on for on and on and on and on and on and on. You look surprised at that, Brent. Or are you just still tick-tocking?
I just did mine wrong. Because I didn't do negative.
Oh, you didn't go down. You just stopped at 0 and bounced it back up.
That's why I was owing.
Oh, because she did. She bounced it.
Yeah, I bounced it. Wait, so this is bad.
So now on this one, when would we go below our new horizontal axes? When we go into which quadrants?
3 and 4.
Give me another chance.
2.
Come on now.
Cordy?
2.
2 and 3, because 2 and 3 is where cosine is negative. Yep.
She's like, it was
Yep.
Ooh, I missed it.
Okay, got it? So if you're looking at quadrants here, so this is quadrant number 1. This is quadrant number 2. This is quadrant number 3. And this is quadrant number 4. Then this is back to quadrant number 1. What?
You like switch from Roman numerals.
Because there's too many eyes.
I respect that.
Okay? Tomorrow we'll go hardcore into talking about the properties and all that stuff. And then we'll get into transformations later on this week.